And today in this webinar, we want to take a look at exploring reality capture in a civil world. And my goal here today is not to really get into the details of how we do all of this, but kind of just let you know what's out there, what's possible. And I will do again, pretty high level demo on some of the things that are possible on the software side of things. So with that, I'm just gonna jump right in. And again, my name's Jay Mezer. I'm a solution consultant here at Imagine. Been in the industry for what seems like forever. Just whether it's on the engineering side or here at Imagine It, being an instructor. I am a Civil 3D professional, and I have the advantage here at Imagine It to get to work with a lot of the reality capture technology. And even though sometimes it's technology that maybe Imagine It doesn't sell or support, I get to see a lot of it, and that's through getting to work with customers and things like that. So it's pretty fun job and pretty interesting all at the same time. Obviously, I get to work with the Autodesk Recap family of products, whether it be Recap Pro or Recap Photo. And we here at Imagine It are a Leica Geosystems reseller. That doesn't mean I'm here to talk about, Leica hardware and all that sort of thing. My goal is to show you different workflows. So also, I get to deal with a lot of the Autodesk software, including AutoCAD, Civil 3D, and simply regular AutoCAD. So I'm going to start with, what is reality capture? Well, reality capture is you being able to create an informed design. That design puts all of your data, your design data, in context with the existing world around you. Using that existing world around you, we can then take the design that you're about to create and do clash detection on a point cloud. So we're able to tell, hey, does that retaining wall I'm designing interfere with anything else on site? Maybe a different retaining wall or something like that, okay? Anything we're gonna retrofit or anything that's gonna change over time, we can verify that retrofit on site, or actually in the computer. So then we can monitor that for any design movement. Anytime we take maybe and design a bridge, we might be able to say, okay, well, we've designed this bridge, it's been built. We can then monitor that and see if that bridge has moved at all. And of course, document the construction process with iterative data collection, just being able to go out every week or every month or possibly every year and scan an area to see how it's changed over that time. We also use reality capture for cultural and historic preservation, right? Being able to show someone what that project looks like so that it does not get changed or its historical value does not get changed. Okay. Now, what about reality capture in the civil world? When we talk about data collection, right, we talk about a wide range of collection methods. Now, some of these things Imagine It sells, some of these we don't, but it's very important when we talk about the civil world that we bring some of these different data collection methods and talk about them, because we might have something like traditional survey equipment, GPS equipment, and we can still use that data to collect data. Some of these will also create point clouds. Okay, they're not traditionally a high definition scanning point cloud, but still they can create a small point cloud. We can talk about photogrammetry or drones and picking up data just using pictures. Why would we use a drone versus a traditional survey data? Well, I can pick up a very large area in a very quick amount of time using something like a drone and photogrammetry. Mobile LiDAR. If you've never seen one of these things, you can strap this to the top of a vehicle, drive down the road, and scan. Okay, create a point cloud just simply by driving. And then, of course, there's our HDS scanning or terrestrial laser scanning, where we can pick up data one location at a time. And, this is slower than some of the other methods, but the amount of data, the amount of detail we're able to collect with something like this, and at the accuracy it's able to collect it at, is superior than some of the other methods. Okay, so let's talk about what can be scanned, because this tends to be a point of contention, right? So I might come in and talk about roadways. Well, what about roadways? We can scan a roadway. We can scan a bridge. Okay? Why do we talk about these things in the civil space? Why would we scan a road as opposed to doing traditional survey methods? Well, by scanning, keep in mind that we are shooting that laser over a distance. Depending on the equipment, that distance might be 100 meters. It might be 200 meters. Okay? In some cases, it might be a kilometer. How does that benefit us? Well, that benefits us because we're able to collect large amounts of data, and we're able to collect it without ever putting somebody in the roadway. We all know that we've all seen construction or survey crews out on the road. No matter how many cones they put out, no matter how many signs they put out, unfortunately, safety is an issue for those folks. There's always somebody not paying attention for one reason or another. Okay? And of course, site design. We can scan a whole site, whether it's the outdoor to lay out the roadways. Of course, it's not the civil space, but we can also scan the entire buildings inside and out. We can tie that data to the site design. Okay. Now I want to talk about a little bit about misconceptions. When we talk about misconceptions, these are things that I've heard people say over the course of my time here, Imagine It, and dealing with reality capture. And some of these are just, because maybe they're not aware of what can be done with reality capture. So one of the ones is I can't use high definition scanning because of vegetation, right? Well, you might not be able to scan the vegetation itself, but remember, we can tie some of our scan data on the hardscape, on a bridge, on a road, on a site, to traditional survey data, okay? And that vegetation can be removed after the fact. The software allows us to select certain types of data and just simply remove it. This is the one I hear a lot as well. Moving objects will ruin my scans. When I say moving objects, obviously I'm referring to cars or people or bikes or whatever. Anything moving through the scan. And simply, that's not true. Moving data can be removed by the hardware in some cases or most cases, and it can also be removed by the software. So that moving data, that person that walks through a scan, we don't worry about them. We let the hardware and the software worry about getting rid of that data. And just as an example, in the case of the Leica RTC 360, it has the ability to do a double scan, and during that double scan, will remove objects that were in one scan but not another. And this was one I heard, this was more early on with scanners as they became and gained popularity. I don't want to throw away my traditional survey equipment. No one's asking you to. No one wants you to throw away your traditional survey equipment, okay? We're asking you to use that traditional equipment in conjunction with high definition scanning equipment, okay? Pick up your survey points that you did before. Allow the scanner to pick up what's in the middle of the road, being, again, going back to the safety thing, okay? So, and another one I've heard quite a bit, well, I have to use a drone, or I have to use HDS scanning, or I have to use mobile LiDAR. Not true. All of these methods can be combined. I can collect an entire site with a drone, and then I can take my HDS scanning equipment out, and as long as I get a couple of common points, I can combine those two types of data and use all of it to create my design. Okay? All right, so let's talk about a couple of different applications. Just simply being able to create survey points and break lines. And I'm going to show what you're seeing here on this picture. I'm going to show this here in a little bit. So I can create these survey points and break lines. So, one of the things I talk about, I live in the New England area, and sometimes in the wintertime it gets pretty cold here. So if I can take my scanner out and scan down my roadway I live on a rather short roadway, but if I can scan down my roadway in about an hour and be able to take that scanned data back into the warmth of the office and turn it into a Civil 3D surface by collecting break lines and survey points, I would much rather do that than be out there for several hours in the cold. Right? DTM creation. We can take our point cloud data and simply turn it into a digital terrain model. Now, I don't have break lines here. I'm not using survey points, but I can create a DTM with point cloud data. And again, these are a couple things I'm hoping to show here if we have time. And then, of course, there's analysis. What happens when we build a bridge and the pier on that bridge has moved slightly over time? How do we get that information? How do we show it's moved other than using traditional survey equipment? Well, of course, we can scan it. We can take that pier and we can compare a solid mesh of that pier to a point cloud and be able to show that, hey, look, it's moved right here. All right. So I'm going to go in and I'm going to do a quick demo here. So bear with me as I jump into my software. And so I am in like a Cyclone product, and there are a number of you, I'm sure, that have used this software before. And I'm going to do a very quick and demo, and so I'm not going to do this whole roadway or anything like that to make sure that you guys understand it. But I'm going to start by saying, okay, well, I want to create survey points for my roadway. I want to, I would normally have somebody shoot somewhere along the center line and then bring those points in as a CSV file. But of course, then they have to shoot the curb. Then they have to shoot the top of the curb, so on and so forth. So I'm going to show you how we might accomplish that same task through using reality capture. Being able to come in here and simply use some pick points. So all I'm going to do is pick on my point cloud. And I'll pick again and again. And notice what I'm not doing. I'm not getting overly worked up about where I'm selecting. I just am trying to get close to that center line. And so then I can turn that center line into a polyline. Now, for those of you out there that are Civil 3D users, what would we want with this? Well, we would want a digital terrain model, we would want an alignment, and we would want a profile. Well, I'm not going to even do all of that. I'm going to come in and create an alignment, set a beginning station, and say, okay, I've now turned that into an alignment, and I can go ahead in and say that I want to look at that alignment. And what's going to happen here is my alignment station manager pops up, and I'm going to tell it that I want to look 30 feet to the left, and I don't want these inches, so we'll just leave that as 0. And we'll say 30 and 0. Now, I want this to cut a section every 50 feet. And I'll go ahead and say create. And you can see what happens is it creates a cross section through the point cloud. So let me try and move this down so we can see a little bit. Now, what would we do with a traditional survey, right? We would come in and we would pick up a point at the back of sidewalk, the top of curb, the bottom of curb, so on and so forth. We can do the same here. So what we can do is use the software to come in and create a template. And I'm simply going to use the point cloud. Now, I'm not going to get overly accurate here. So for those of you out there saying, well, he missed a point by a little bit, I'm just going to do this rather quickly. Okay. And I'm going to go ahead and pick a point here, and we'll pick a point here. Now, I'm going to come up maybe right there and right there, and sure. Okay. Now, notice if we look real close in between here, I didn't quite get a point that I wanted. So I can come in and I can add a point in if I forgot one. And I'm going to call that good for now. Okay. And so I'm going to then say, create a template. Sorry, my mistake. Let me try that again here. There we go. And so now each point can be labeled. I have the back of curb. You can see now my survey point shows as back of curb. Then I can do my top of curb. And just go kind of all the way over as much as I want to do. Now, if there's something that maybe I didn't include, like let's say for whatever reason gutter wasn't here, right? I could simply just type that in. It is here, so I'll just simply select it. Whoops. And then we just go ahead and center line. We'll come over and gutter right. Bottom of curb. I chose the wrong one. Oh, my mistake. I used the wrong one up here. So I'm going to say this is back a sidewalk. Sure. And then I'll come down. Okay, so I then have my survey points in on my first station. I can save that template. And I can go from this 100-foot station to the next 100-foot station, and we quickly see that, well, geez, that template has changed a little bit. Why? Well, I'm sure my road's going up or down a little bit. So what we can do is we can select that and we can edit where we think these items go. And again, I'm going to just simply get a rough idea here and try and get them a little bit closer than they are, just so you can see. And then we step to the next one. And so if your curbing dips down, guess what? You're going to see that in this section view. Right? And so I'm at the end here. I've got 3 sections. I say, yep, okay, that's great. I'm done. I want to go ahead and create COGO points and create break lines. Now, I can create those as objects here in the software, or I can export them directly to a land XML. What takes in a land XML? Well, again, if you're using Civil 3D, Civil 3D does. We can import those as COGO points and break lines. Or we can say create objects and create them here in the software. And we can close our software and zoom all. And put points in. Okay, now I use these ones here. I put them, I did a little bit earlier, but I now have all this data. And of course, I can export this as AutoCAD data. I can export this as a CSV file as points. And once again, be able to then bring this data in to Civil 3D. Okay, and of course, create a surface out of that type of data. Now, what happens if you don't have Cyclone Survey and you don't want to spend the money on Cyclone Survey? Well, that's fine. We can go ahead over to Civil 3D and we can bring Point Cloud in to Civil 3D and do something similar, except it's a little more work. But I can start by creating a 3D polyline and snapping to the point cloud. Okay, and once I snap to the point cloud, I now have a line, and if we look at its properties, that line has a different elevation, of course, at each vertex. So I am pulling the 3D data off of that point cloud. We can flip it up on the side. We can look at curb data, and I don't know how well you guys can see that, but it's okay here, but I'm not sure if you can see it there. But I can also open something called a Smart Pick viewport and start that 3D polyline again, and then I can go ahead and pick on the point cloud. And if you see that it's not snapping to my cursor, that's because I'm telling it to pick the highest point on that curb face. So it already knows that, hey, your cursor's not the highest point, so I'll go ahead and select the highest point. So I can start creating my top of curve. Okay, once again, I'm doing all of this in the office as opposed to doing it in the field and having to put up, put the survey equipment up on the curb, take a shot, and then move down. Okay. Now I know that there's a number of people out there that will sit and say, well, geez, that seems like a manual process, and I got to go and trace all that curve. Well, in using this method, yeah, sure you do. Okay. But there are a number of different methods out there, one of which is using a different piece of software. Now, what you're looking at here is Cyclone 3DR. And we can come in here and bear with me while I and in Cyclone 3DR, I've got the same data set. You can see it treats it as it's very lightweight, right? And we can come in with this and I can just extract a polyline. Now you're going to be thinking, well, if I'm going to do it here, why not just do it over in Civil 3D? Well, because watch what happens in Cyclone 3DR. I'm going to simply grab a polyline. I'm going to finish that polyline and exit the command. And so from here, we can then select our polyline that we just created, and Cyclone 3DR has a script built into it. By the way, these can always be customized and rewritten and written to do things that you want them to do. And I can say curb extraction. I can put in the information about my curb. And assuming that this information is correct, I can then say, okay, and now have the software start to automatically find the top and the bottom of the curb. Now this will go until it can't see point cloud data anymore. There's a sewer here. It might kind of kick out on me at the sewer, and then it tips down, and it actually worked very well. And it's still tracing my point cloud. At this point, I get up, I go get a cup of coffee, wait for this to finish, right? Of course, I'm not going to bore you making you watch the whole thing go, but I will hit stop here and show you how far it got just in that little bit of time, and then show you that, hey, what happens if we go ahead and turn on all of the data and we turn off the point cloud. We can have it create this line work for us. Now, I'm going to show you another cool feature here, but I just want to make sure that I have a drawing open in AutoCAD. This ends up as just line work. I can take all this and I can select it, and of course I can then just do a send to AutoCAD. As long as I have a drawing open, I brought my other one in. Let me close this real quick. Different units. My mistake. But it's that easy to send the data from one to the other. Of course, assuming you have your units correct. Now, when I look at this in AutoCAD, once again, properties, it's a 3D polyline. We can use those as break lines in a surface to create a civil 3D surface. Okay. Now, on occasion, I'll hear from folks that say, well, that's wonderful, but what if I need a DTM, but I'm not a civil 3D user? I don't need those break lines. I don't need the points. That's okay. You don't have to use them. Once again, I can exit out of here and I have many choices. I can open the point cloud, right? Actually, let me show you a different point cloud because that one's a little big for what we're going to do here. I can open a point cloud and you can see there's just a ton of data. Remember what I said earlier about moving data going through my point cloud? Well, there's a bunch of cars. You can see the mirrors, right? Well, I'm not using Civil 3D for this. I'm using actually Cyclone 3DR. So what we can do is we can come to the surface modeling tab and say that we want to create a DTM. But before I do this, I want you to take note of what's going on here. Notice the side slopes, right? And there's obviously a bunch of trees. But if we zoom in here and we look underneath all the tree cover, there still are ground points in there. So what we can do with that, excuse me, is use the DTM command and tell it, hey, look, I'm going to allow for such a steep slope. In this case, I have it set to 53 degrees. I want all my points to be on the ground, and I want it to create a refined mesh. So I then can say, preview that data. Now that I've previewed it, you can see that it went ahead and not only did it clean up the point cloud, but it removed the trees and used the underneath points to create a mesh. We can see the ditch along the side here. And if I say okay to that, and I say, well, okay, let's turn off the point cloud, that's what you're left with. So then we can say, all right, well, I want that to be part of Civil 3D. We can come over, we can export that selected object, and we can take it to a land XML format and save, export. Back over in Civil 3D, insert land XML and import my ground data. I have a Civil 3D surface that I can show with contours. Remember the ditch I mentioned, contours for the ditch. So obviously, is it a perfect surface? No, it's not a perfect surface. I'm sure there are things we would have liked to have had in there. This is where we incorporate a couple of picked up points from our traditional survey equipment and add them to our surface. If we created brake lines with that equipment, add the brake lines. All right, so I do have one more thing that I'd like to show, and let me close this out. And once again, I'm going to jump to 3DR. And in 3DR, I want to go in and let me think. I'll create a new one. And I'm going to use an LGS file. Now, this is CloudWorks for 3DR. It comes in 3DR. Anyway, my data is in LGS file format. So I'm going to import that. Now, one of the great things about this is simply that the data comes in and it ends up being very lightweight, right? So you can see it's easy to work with. But even still, I'm interested in this pier right here. And again, I talked about things moving. So what I want to be able to do is I want to be able to draw a box. And if I look at this from the top, one of the things we always run into with point clouds or laser scanning is simply that the data comes in, but it's often not at the angle that we want. No big deal. We can come in, and of course you can do this in AutoCAD and Civil 3D too, but I'm going to then just simply click to create a UCS, just customized UCS. And so now when I go to view and top, kind of rotates it in a way that I like. So from here, again, I don't need the whole point cloud. I don't want the whole point cloud. So what do? I pare it down. I'm going to create what's known as a limit box. And I'll bring this up, and I kind of missed my pier a little bit. That's okay. I can edit the limit box at any time simply by double clicking on it. Pull this out. We'll pull this in a little bit. And we'll make our limit box work. Okay. Pull up just a little and pull in just a tad. Okay, so that's what I want. Now, with that, I'm going to then convert this data over to a point cloud in Cyclone 3DR, and basically, I'm getting rid of the rest of the data. Shouldn't take very long at all. There, it's done. And now I can go ahead and turn off that limit box. Now, with this, I'm then going to go ahead and I'm going to bring some data in from a directory on my hard drive. And it's just an STL file. I'm going to drag it, I'm going to drop it, and I'm simply going to say import. And you can see that if I turn off the point cloud, it's a mesh. Now, what we're doing here is we're taking data that was collected maybe a year ago, and a mesh was created out of it, and we're comparing it to the point cloud. So what we can do is select both of them and analyze them from the cloud to the mesh, right? So then I'm going to say preview that data, and we can see that it gives me a couple of different colors, showing me that there is a difference from the mesh to the point cloud. And if I'm okay with that, I simply say okay, and then I can even come out and I can say that I would like to, select that and extract some sections. You can see I'm extracting sections along my y-axis, but they're not quite where I want them. So I'm going to pick here, and I'm going to pick over here. And we're going to say that we want every 10. Okay. Oop, I must have got a wrong distance here. Bear with me. There we go. Move that back to 50. And I'll say okay. And now if I look close, I have sections showing that mesh and they can be compared again to the point cloud. So there are just a number of ways that we can use high definition scanning equipment in the civil world, right? Whether it is a roadway or a site design, or in this case, a bridge.